Good morning, YouTube. Hi, I'm Greg from GregsTutoringNYC at gmail.com. So I'm going through the 2017-2018 student handbook for the SHSAT. If you guys need a copy, please email me. I can get one to you. And if nothing else, you can just follow along on the screen. So I am up to the multiple choice problems on this test today. I tried to do this live from Bryant Park yesterday, and let me just say it was a royal screw-up. I might try it again because I'm going to be around that area basically every Saturday, maybe even Sundays actually too. And it would be great if it worked because even though the Wi-Fi was reasonable at points, it was also very unreasonable at other points. So I need to figure out kind of the best way to get through that. All right, anyway, so I'm redoing the live stream from there yesterday. I went over a bunch of questions and the playback is just horrible. Half the time it's me trying to do stuff, and the other time is the problems didn't come out right and other stuff like that. So without further ado, let's jump into this. So let me just make sure the stream is going. Yes, it seems to be okay. It's got me talking. There's probably a lag as well as usual. So let me bring up the questions on my side. So question 63, so again, always read the directions. Mark your answer on the bubble sheet. In this case, there's no grid-ins for this. By the way, you can write on your test sheet all you want. The form that you're seeing on the screen now, you can solve your problems in a little space there and so on. Most problems are set up so that you basically have enough space to do it. And if you have to do it twice, then you could still find another space for it. And I believe you're allowed to ask for scrap paper if you need it as well. And my phone just died. Let's give this a take two. And are we back? As we seem to be back. No, exactly, not exactly 100%. No, we just lost that. Blah, 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 blah. 1 second. I can't tell if we're back or not. No, we're not quite back. Technical difficulties are always wonderful things. All right, there we go. All right, so where's my pen? All right, first question. The set of possible values for M is 5, 7, and 9. So we have some curly brace kind of thing with stuff inside of it. And those are expressions. When you have the curly braces, which is normally your shift square bracket on a lot of keyboards, that institutes a set. We can have variables in here, x, y, and z. We can have expressions like x plus 1, comma 5, comma 9. Okay, so it's telling us we have a set with 3 items in it, and it's what is the possible values of the set with involving k for 2k, equals m plus 3. So what we eventually need to do is take the set that they gave us and substitute each respective m into there to get a new set for k. All right? So basically at this point we have an algebra problem. We're going to solve for k. K equals m plus 3 over 2. So what we're going to do is try each of the set one at a time. So we're going to do it for 5, because that's the first item in the set m. So we have 5 plus 3 over 2, and we get 8 over 2, and that is equal to 4. Okay, we're going to try it for 7, so we get 7 plus 3 over 2, so we get 10 over 2, and that's 5. So we have 4, 5, and then we're going to try it for the third item. We get 9 plus 3 over 2, and that's 12 over 2, and that's 6. So we need an answer where the new set for k is 4, 5, and 6, and that's B. So 63 is B. All right? So a lot of you guys are unfamiliar with sets. That's really the minimal for that. This doesn't come up too often, sets, except for in this guise, in this form. So that's more or less what you need to know about it. You don't really need to know much more about it, okay? And you could also plug values in. This one was easy peasy. It was really just trying to match if you could do that kind of a thing. And it has a little algebra issue thrown in. Not a big deal. So that to make sure that you solve for k, basically. Enough of you are going to do this in your head. Again, I would refrain from that, but that's me. Okay, 64. Okay, so we have one bottle contains 500 milliliters of juice. How many liters of juice are there in 12 of these bottles? So what we're going to set up a relationship. 1 milliliter, one bottle is to 500 milliliters, okay? As 24 bottles is to how many? All right, so we can do the cross product. So we get x equals 24 times 500. So x equals 12,000. This is in milliliters, though, and they want the answer in liters. So the conversion between a milliliter and a liter is thousands. So divide by 10, divide by 100, divide by 1,000. So we should get 12 as the answer. Okay, so this dealt with unit conversions, and it also threw in the ratio kind of situation we have to do. And don't get bent out of shape with that. So this kind of question is going to come up on every SHSAT, and it's a point thrown away because a lot of kids forget what the unit conversion is. And again, remember, this is different than the state test. They will not give you the unit conversion. They will not give you formulas. So these are things you're supposed to know. So just give it a review before you get in there. There's guaranteed to be one question here, and you don't want to be the question that's worth 10 points. Remember how this is scored, that the more questions you get right, the more some of the points are going to be for some of them at some point in the line in the sand. So basically the first 5 questions might be worth a little more. Then the whole middle point questions are going to be worth about 4 points. And then after about question 38 or something, questions are going to start to be worth more points. So this is the number of questions you answer, not literally question 1, question 2, question 3. But if you get 38 questions correct, then every question you get correct after that is going to be start to worth more points, sometimes up to 10, 11, 12 points. So getting this right could be worth 4 points. It could also be worth 10 points. It could be worth more. Depends on the year, the test, how they curve it, a whole bunch of issues involved with that. But you don't want to throw away a point. In this case, it's not a point, it's many points. Okay? This could be the question that decides your cutoff score. A lot of kids fall into the cutoff score area. Remember, they're applying a statistical model to your grade to get your score. Right? So it's not just the number you get correct here. The handbook is slightly misleading by saying every question is worth worth a point. That is actually not true. Okay, it's certainly not true when it gets to be your score, right? And then they add the two together, which is why you want to ace a section as much as possible, as much as you can. Okay, that's 64. 65. Let me just make sure the stream is going okay. Yeah, we see him all right. Let me just check something else here. Okay, so 65. In a certain school, course grades range from 0 to 100. Fine. Adriana took 4 courses, and her average course grade was 90. Good. Roberto took 5 courses. If both students have the same sum of course grades, what is Roberto's average? Let me get a piece of paper. So we know that her average is 90. Okay? She took 4 courses. So the sum of her scores is 360, because 360 divided by 4 is 90. Okay? It says Roberto took 5 classes, but the sum of their grades are the same. So Roberto is going to be, we don't know what his is, right? But we know he has 5, and his is also 360 then. So the question is, what is that? So basically we have 5x equals 360. That's the mapping of the words to the math. And let's run through it again. At a certain school, course grades range from 0 to 100. Cool. Adriana took 4 courses and her average was 90. That means the total of all of those was 360. All right? Roberto took 5 courses. If both students have the same sum, that's the 360, right? What is Roberto's average? So it's just a matter of dividing by 5 on both sides. So 5 goes into 360. We have 5, 7, 35, 1, 5 went to 10, 2. So we get 72. And we can feed that back. 72 times 5, 0, 1. We get 360. Okay, and that was hers as well. So his average is 72. All right? So there will always be kind of this test question. It's going to either take this form, or it's going to ask you to figure out one of the grades of one of the students, or sometimes 2. So it might give you 4 of Roberto's classes and ask you to do the 5th. Or it might say there's a final exam, and the final exam is worth 2 tests. So make sure you just don't make that the x, you make a 2x. And then you can take the average of the 2 and figure out what the final would have been by dividing it by 2. All right? So there's a lot of different variations. This is true of all the questions. So be careful as you're reading and make sure you're doing the mapping of the English to the math properly. 65, 66. Let me see if this actually fits on the screen with the worksheet in the way. No, it doesn't, so let me drag this down slightly. Okay. So Jenny starts a game with twice as many marbles as Keiko. Jenny gives Keiko 5 marbles, but still has 10 more than Keiko. How many marbles did Jenny have to start with? So this is our classic age problem. This will be on the SHSAT at least once. This is not involving age, but it's involving somebody giving something back and forth to somebody else. So what we're going to do is, as usual with any word problem, we're going to take it a sentence at a time, and then break each sentence down into phrases. So Jenny starts a game with twice as many marbles as Keiko. Jenny is equals twice Keiko. Okay? Jenny gives Keiko 5 marbles. Okay, so we're going to take it a phrase at a time. So we have another expression that we're going to set up, another equation. So Jenny gives Keiko 5 marbles. So Jenny has 5 less, and I just automatically parenthesize this. And I'm all going to work on the first phrase. So if Jenny has 5 less, she gave 5 to Keiko. So that's our thing up to the comma after the 5 marbles. Jenny gives Keiko 5 marbles. But she still has 10 more than Keiko. So if we just said straight up that Jenny has 10 more than Keiko, we'd be like that. That's how we can be equivalent. So if Keiko was 1 and Jenny has 10 more, she would be 11, right? So even though we put this and this here, we're still going to work it the same way. So we still just add 10 here. All right? So before you start actually trying to solve this, let's run through it one more time. Jenny has twice as many marbles as Keiko. Yep. Okay. Jenny gives Keiko 5 marbles. That's this here. Okay. What I'm going to do is basically underline each part that I did. And Jenny has still 10 more than Keiko here. All right? So that's our 2 expressions. That's our 2 equations. So there's a couple of ways to do this. One is wherever you see a J now, replace it by a 2K. That's here. So we have 2K minus 5 equals, and we don't need the parentheses anymore. If there was a multiplication involved, we would have to maintain the integrity of the parentheses to ensure things like the distributive property and so on get done. But in this case, we only have addition and subtraction. So we can throw the parentheses away. And we get K plus 5 plus 10. So that's the same as K plus 15. And we get 2K minus 5. So what we're going to do is add 5 to both sides. We get 2K equals K plus 20. And then divide by 2. No, sorry, we're not going to divide by 2. We're going to subtract K from both sides and get K equals 20. And we're going to divide by the 2 on both sides and get K equals 10. Something tells me I've done something wrong here. Let me just run this through again. 2K minus 5 equals K plus 5 plus there. 2K minus 5 equals K plus 15. 2K. Yeah, there's no 2 anymore. So it's just K equals 20. My last step was wrong. So if K is 20, then J must be 40. Okay, and if we run that through on the second line as well, if J is 40, then this becomes 35, right? And then K plus 5 is 25 plus 10, and that's also 35. So it checks out. So always take a word, this classic, it's called an age problem, but take the numbers and feed them back in. If you don't feed them back in, then you might as well just be randomly guessing. Okay? The numbers have to work back. If they don't, you've probably done something wrong. Either you did the minus here wrong, the plus here wrong, or the 10 wrong. Maybe it should have been on the other side or something like that. Or the word problem was more involved. All right? Okay, 67. Let's try to get that to fit on the screen at the same time. Yes, it does. So in the scale figure, in a scale diagram, 0.125 represents 125 feet. So this is inches. So when you see something like that, just set it up as a fraction. Okay, it's a ratio basically though. So how many inches is represented in 1 foot? So this is X over 1 foot. So this would be inches. Okay, enough you can do this in your head that you see this is divided by 125 to get 1, and you divide that by 125, you get 0.001. Okay? So that would be A. You can also do the cross product. You're going to get 0.125 equals 125x. Divide both sides by 125. And you can see that goes into 0, 0, 1 times, okay? We don't even need to do it. If we do 1, 2, 5 into here, 0.125, we get 0.001, okay? So this is the kind of problem you can do in your head. Others you should avoid. Okay, that's 67. So some of these are not too bad today. Okay, 68. Let me make sure that's showing on the screen because that takes up the whole side there. Yeah, 68's good. So we're going to look at the illustration. In this case, the illustration happens to be a table. So it says people per vehicle at checkpoint. So we have 2 columns, number of people in vehicle and the percent of vehicles. So 1, 2, 3, 4, and 5 or more, 40, whatever. So I just like to see if things jive. So is 40 plus 35 plus 15 plus 7 plus 3 equal to 100? You got 75 plus 15, 85, 90 plus 7, 97 plus 3 is 100. So that does add up to 100%. I'm just trying to make sense of the table and trying to do stuff. So how many vehicles had 15%? 3. How many had 2 passengers? 35. Okay, so we kind of beat that to death. So now let's look at the words. A researcher recorded the number of people in each vehicle that passed through a checkpoint. Okay, that's what the table said at the top. The table above shows the percent distribution for the 420 vehicles that passed through the checkpoint. So this is specifically relating to 420 vehicles only. Okay? How many of the 420 vehicles contained at least 3 people? So let me try to kind of write the table real quick. So you have 1, 2, 3, 4, and then 5 plus. And we have what? 40, 35, 15, 7, and 3. So it's telling us, or it's inquiring of us, at least 3 people. At least 3 people. So it's these 3% here. Right? We're talking about everything from this point down then. At least 3 people. So if it's at least 3 people, it includes 3 people. All right, so if we add this up, that's 10. So this is 25%. Right? So another way to rephrase the question is 25% of the 400 people had at least 3 people. So let's just do that. We get 25% of 420. Of means multiplication. And 25% is a quarter. So we get 420 over 4. Right? We can do long division. We get 105. We get 105, which is G. All right. Also, you guys can do if you have a number like this, if you have it, you get 210. And if you have it a second time, you get 105. So that's how to do fast division by 4. You can do multiplication by 4 the same way. If I have 105, I'm going to double it twice. I get 210, I get 420. All right, you guys got that? I think it was off the screen for a second there. So divide it in half, and divide it in half a second time. Okay? I'm not saying not to do this way. I'm trying to give you alternates to be able to double check things. All right? So this was really about reading a table properly. It wasn't really deep math. So be careful with this kind of question. All right, the next one is falling off the screen, so let me move the camera to the other side. And I need to be careful here. I don't like when it's this way because I often start writing and you guys can't see what I'm writing. So let me see, where's the part where the camera's okay here? Is it there? All right, yeah, so I can write past that point. Okay, so we have an illustration. So let's beat the illustration to death first before we look at the words. So we have a pyramid, a triangular pyramid. actually it's a rectangular pyramid with 4 faces that are triangles and a base which is a square or a rectangle. Does it tell us? Yeah, I'm going too fast at this point. Anyway, it's a square. Anyway, so it means that, I mean, move this over just a smidgen still. So we have base MNPQ, which is a square. We also have 4 triangles, MRQ, QRP, PRN, and NRM. So we have 4 triangles. We have line segment RS, which meets line segment QP at a right angle. So we can almost tell off the bat that it's probably going to ask for the area of that triangle, right? Because they're giving that to us. Either that or it's a distraction, and the SHSAT doesn't go that deep in distractions. So normally when they're giving us something, it's to our advantage. They're not giving us any of the numbers that I could see, at least on the illustration itself. But we have a lot of details to work with there. We almost have a heads up just by looking at it. And again, you're making a snap decision. I'm spending a minute or two talking about this, but you're going to observe it, try to reach some conclusions, ask yourself some questions about it. In other words, I looked to see if MNPQ was a square, and it is, but it could have been a rectangle. That may or may not be important to the problem. All right? And so let's go to the words now. In the pyramid above, each triangular face has the same area. So each of those 4 triangles I mentioned before are the same. And the base MNPQ is a square that measures 8 centimeters on each side. If the length of RS is 6, what is the surface area of the pyramid excluding the base? All right, so what we have is each triangular face, because the length of the side of the square is 8, that means QP is 8. So the length of here is 8. Okay? RS they're telling us is 6. So we can immediately leap at the area of this triangle, because the area of a triangle is 1/2 BH. And we have those 2 numbers. So we're going to get equal to 1/2, 6 times 8. And we're going to get 48 over 2, or 24. Right? And we have 4 of those. We have 4 faces. And that's equal to 96. By the way, here's an example of multiplication. So we double this, and we get 48. We double that, and we get 96. All right, so this is no hesitation math. This is working with your numbers, getting a number sense out of them. All right, and you can also double check it by doing the 24 times 4 on the side. So let's read through the problem again and see what else we need to do. In the pyramid above, each triangular face has the same area. Cool. And the base, whatever, is whatever. Cool. If the length of that is that, what is the surface area excluding the base? So that's our answer there. For that, we should get B. That's 96. All right, let's just make sure we're still going live. All right, we're about half an hour here. I'm going to keep this about an hour, so let's see how far we can get in the next few questions. We have 2 live viewers. Hello, everybody out there. Hello for those of you catching us on the replay. If you have any questions about this, please feel free to ask. If you want to email me, my email's at the bottom. If you want to join here live, that would be great too, so we can get an interaction going. Please like and subscribe to the video. I'm going to be going through this and a whole bunch of other stuff. I have dozens of other live streams as well, so that's something you guys may want to consider to look at. In addition to going through this specific 2017-18 handbook, I have videos about a whole plethora of different stuff. And then when we get at the end of this, I want to decide what to do. I do say cover to cover. I'm not sure I want to do the second half here. That said, a lot of kids have a problem with the revising and the editing stuff. So I might do that. And there's also always the grade 9 stuff that everybody puts on the back burner. I do that because the premise is grade 9 includes grade 8. So you need to master the grade 8 material as well. All right. And the amount of grade 9 specific stuff only is a small percentage when you look at it. Even if it's 30%, I don't know the exact number, it varies from year to year. But even if it's 30%, that other 70% you need to master, even if it's just grade 8 stuff. And on the flip side, the grade 8 stuff could have more harder questions in it, which is why you should be playing around with the grade 9 material, even if you're taking the grade 8 SHSAT. In other words, whichever SHSAT you're taking, you should become more observant of the other grade stuff and master it as well. All right, so where are we? Okay, 70. All right, 70 is kind of a nasty problem. Let's see, if I just flip this around, will that work? Because I'm going on the half-page stuff. Let me try it on a blank one, because the real estate I have here is kind of small. So it says the perimeter of a rectangle is 510 centimeters. No, that's not working. Where does my pen start? Right there. Okay, so it means if this is x and this is y, I'm going to have x plus y plus x plus y equals 510 centimeters, right? Or we can just say 2x plus 2y equals 510. Depends how we want to do it. We can also say 2 times x plus y equals 510. All right? And if we go another step, we can even divide by 2 and do x plus y equals 255, I believe. That's 250 times 2 is 5, yeah. So that's 255. Okay? The ratio of the length to the width is 3 to 2. So if we consider this the length and this the width, okay? So there's a 3 to 2 relationship there. 3 to 2. Okay, what are the dimensions of this rectangle? Now, we can go ahead and try to do it without looking at the answers, but in this case, we want to use the answers to our advantage because there might be a whole multitude of different answers here. There could be 5, there could be 100, okay, given how we yin-yang the thing back and forth. So what we want to actually use is their examples. So, so they're asking what are the dimensions. So I brought this down to here like this, where the x plus y equals 255, because any dimension they give you has to end up being 255. Because the answers like the 150 and the 105, they're the x and the y, they're the length and the width. Okay, so there's 2 criteria we have in trying to solve this problem. The first is that the length and the width have to be equal to 255. And the second is they have to be in a 3 to 2 relationship. Okay? So if we look at E, so we have 150 plus 105. That is equal to 255. So that passes that test. So now the question is, are they in a 3 to 2 relationship? So it'll be 150 by 105. Okay? So one way to check is to divide this by 3. Okay? And we get 50. And if we take that number and multiply it by 2, we get 100. So then they are not in a 3 to 2 relationship. Okay? And this is just the cheap way of doing the cross product. Right? So what we're checking to see is if 150 over 105 is equal to 3 over 2, basically. So we get 300 is 315. Okay, so that's not true. So these these two fractions are not equal. Therefore, I'm showing you two different ways to double check that the answer can't be E. So now if we work with F, F gives us 153 by 102. Okay, so does this add up to 102? We get 5, we get 255. Yes, it does. And then the other criteria is if we can verify this in either way of these. So if I multiply this by 3, I get 51. So it's 51 times 2 equal to 102? Yes, it is. So therefore, the answer is F. Okay, and I could have set it up as a fraction here as well. I'm just showing an alternate way to view this so that you have a way to double check, or at least another way to think about problems like this. And if we run through G and H, we'll have the same thing. So G, we get, let's just do it. Do I have scrap paper here? Yes, I do. So G is 158 by 97. So we get 158, 97, we get 5, 1. That's 255. And if I divide this by 3, it actually doesn't divide evenly. That doesn't mean it's no good. But if we were to flip it back out, so we get 50, 52 point something. If we multiply this back out by 2, it's already above 97. So it can't be G. And then H gives us 165 by 90. That is 255. So I'm going to divide this by 3. And I got 5, 1. I get 53, and 53 times 2 is 106. So that doesn't work either. All right, so it all confirms that the answer is H. And it could just be worth running it through one last time, because you want to make sure you're doing the relationship 3 to 2, not 2 to 3. All right, and that's probably where one of those ended up being the case, that it was 2 to 3. Yeah, I'd have to run them through. So that's our situation with those. All right, let's see, what do we got going on here? All right, so what you want to just do is take each problem, take a bite-sized piece, and work through it. Okay, 71, let me move the camera out of the way again. So this kind of problem is also on every SHSAT, and you want to be careful with it. So number line always shows up, and this is also inequality at the same time. And then there's the visual mapping of it back and forth. So I like to look at the figures first. So what we're going to do is run through the, just look at ABCD first. They're all going from -10 to 10. And there seems to be a focus between the midpoint area. So the first goes to about -2 to 1. The second goes from a -4 to 2 or so. The third is basically less than 8, -8, and greater than 4, it looks like. And the last is going from -8 to 4 or something like that. And realize that each endpoint there these are holes. They're not filled in. Okay, since they're not filled in, it doesn't include the endpoint. All right? So we learned a little bit about the number lines and their ranges and so on. So let's go to the question. Which number line below shows the solution to the inequality -4 less than x over 2 less than 2? Okay? I like to solve this in two different ways, which is -4 is less than x over 2, and also x over 2 is less than 2. This one's easy enough to do in your head, but again, I just don't want to do that. So I need to get x by itself. I need to multiply both sides by 2. So I get -8 is less than x, and I'm done. Same thing here. I need to get x by itself. I'm going to multiply both sides by 2. So I get x is less than 4. Okay, so now I have two inequalities. Sometimes you can merge them, and sometimes you don't have to. So if x is greater than minus 8, and it's also less than minus 4, that includes everything inside of there. So sometimes we can write it like this. They're not asking you to do that, but you're trying to make logical and physical sense of this. So now what you want to do is test a number. See if a number in there makes sense. And also test it against the original thing. In other words, if x is 0, does that work here? Yeah, it's still in there. If x is 0 here, does that include it? Okay, try to go up to the end point, like 3. If it's 3, we get 1.5. Does that still work? Yes. And we can do something like go up to minus 7 and get minus 3.5, or 3.5, the same thing. And we can also go to the endpoints. So if I actually say it's 4, right, I get 2 is less than 2. That doesn't work. That's true because that's not less than or equal to, it's just less than. And if I do minus 8, I get right at the minus 4 again, and it's not less than or equal to. So that works as well. So our inequality checks out in a lot of cases. We can also do something like minus 10, and we get minus 5. So that doesn't work in either case. All right, so what we're doing is we map the inequality to something more reasonable, and we're just checking it out now. All right, so now the question is, which number line matches this? The minus 8 less than x less than 4. Okay, A goes from minus 2 to 1. So it's not that. Okay, B. B goes from minus 4 to 2. That's not it either. C goes from, where am I? C goes from x is less than minus 8. No, this says x is greater than minus 8. C also says that x is greater than 4. But no, x is less than 4. So be careful here. All right, that's the exact opposite illustration that we need. Which leads to D. These are the only answers, so it better be it. And we have it going from x going from minus 8 to 4, but not including it, and that maps directly to what we have. All right? So that's 71, 72. Whoops, let me see here. All right, we're still going live, so we're good there. 72 is here. And my phone just died again. Actually, it's still live, though. All right, so I'm not going to touch anything. I'm not sure why. My cable might be loose or something, so I'm not even going to breathe. So we have not an illustration, but we have something stuck out here. So I normally like to look at that first. I consider this my illustration. It's telling me $1 is equal to 7 logs. We don't care what a log is. And $1 equals half of a dolt, 0.5 dolts. We don't care what a dolt is either. So this notion of currency conversion or unit conversion or whatever, this comes up in every SHSAT as well. So far, this actually looks like a simple one. Normally, they're more involved in this. And what we're trying to do is probably convert dolts to logs or somehow add things up based on $1. Because, for instance, we know if $1 equals 7 logs and $1 equals 0.5 dolts, we also know that these two must be equal. Because if that's $1 and that's $1, then this is equal to that. Right? I'm going to do a double thing. It's kind of a weird looking equal sign. So that may not be the question, but again, we're just looking at the illustration, or the faux illustration in this case, just to try to make sense of what we're being presented with. All right? So now let's read the problem. Kevin has 140 logs and 16 dolts. If he exchanges the log and dolts for dollars, according to the rates above, how many dollars will he receive? Okay, so in this case, we actually don't care as much that these both convert to $1 or that these are actually equal. Okay, what we're going to do is just set up our situation. So if we have $1 is 7 logs, right? and they're telling us he has 140 logs. All we're trying to do is solve for x here. So if we do the cross product again, when you get 140 equals 7x, and then if we divide by x on both sides, 7 by both sides, we get 20 equals x. Okay, we're going to do the same thing here. If he has 16 adults, we have one adult is 0.5. $1 is 0.5 adults. By the way, that's the problem with using D for the symbol. So let me put adult here. Equals, and the same thing, x over, where's the number, 16. So we do the cross product, we get 16 equals 0.5x. Divide both sides by 0.5. And a half goes into 16. This is the clincher of the problem. So even if you set it up properly, be careful here, right? If this was, let's say the bottom was 32, you get a half. If the bottom was 1, we get 16. Since this is already a half, we're going to get 32 out of this. Okay, and you can also do your long division. 0.5 into 16. We move this over 1, we add a 0. Okay, so 5 goes into here 3 times 1, we get 32. There's a couple ways to solve this. So this x is equal to 32. So there's our two things there. So let's run through it again. Kevin has 140 logs, so he ends up with $20. He also has 16 adults, so he ends up with $32. If they exchange the logs and dollars for dollars, how many dollars will they receive? We're just going to add this up. We're going to get 20 plus 32, and we're going to get 52. So the answer to 72 should be F. All right? So again, this is a simpler one, and the real whammy was the half. And again, this is a reason maybe to do it, not do it in your head, because it's easy to think it's a half of 16. Right? Let's focus on this for a second. So if I have 16 divided by 0.5, it's easy to look at that as if it's a half of that it's 8. But that's not what this says. It's not 16 divided by 2. It's 16 divided by a half. And if we write the half out, we have 16 over 1/2. Okay? That's the same as saying 16 divided by 1/2. And division by a fraction is the same as multiplication by its reciprocal. And that's equal to 32. All right? Be careful, because that's probably where the 28 comes from. Yeah, we would get the 20 plus the 8 if you did it as in 16 divided by 0.5 is a half. And this is going to be the death of a lot of kids. And again, this is a giveaway question. And again, if you're talking about the number of points again, you want the 10 points and not the 4. Okay? So your first goal is to get at least 38 questions right in each section, not just the math. And then start getting the extra points for each additional question that you get right on there. All right? Again, the questions are graded on a curve, so like 38 might be 4, and it depends each year the exact thing here. So I'm just talking generally here. But if you got 4 points for 38, you might get 6 points for 39, 7 points for 40, 8 points for 41, and so on. Do you guys see where this is going? Again, the numbers vary per year, and it depends how they set up the curve. All right? Okay, 73 is already on the side there, so we'll just leave things as they are. Just let me make sure we're streaming. Okay, so a box of colored pencils contains exactly 6 red pencils. The probability of choosing a red pencil from the box is 2 out of 7. How many of the pencils in the box are not red? Okay, so what we're going to do is take this a sentence at a time. So normally when this is a probability question, normally we have probability, and they're giving us the counts. And we normally have to produce the fraction. In this case, they're giving us some of the counts and some of the fraction. So there's 6 red pencils, okay? And and a bunch of unknowns. We don't know how many. So we can't do the total, because normally that's how I like to set it up, but we don't know that. But they're telling us a box of red contains exactly 6, and the probability of choosing a red is 2/7. All right? So that means the probability of choosing any of the others is 5/7. All right? How many of the pencils in the box are not red? So 2/7 is 6. 2/7 equals how many of 6 is what we're going to try to get out of this. 2/7 is 6. So basically, if we figure out the 7th thing, we get 42 equals 2x. Why did I write 74? I have no idea. 42 equals that, divided by 2, we get 21 equals x. Okay? And it's as simple as that. Because we have 7 sevens altogether. So if 2/7 is 6, right? That means 1/7 is 3. 2/7 is 6, 1/7 is 3. Right? So we're going to multiply that by 7 and get 21. This is an alternate way to do it. All right? Yeah, how you doing? How you doing? I'm probably going to do a couple more questions here. Let's see, what's the time here? 10:12. Yeah, I'm running an hour here, so you're catching me at the end. 75. 75 is being blocked by the camera. Okay, 75 is really a throwaway problem, but let's do it anyway. Hopefully the pacing of your SHSAT prep is going well. I think we're at 40 days today, guys. So you have about a month and a week or 2 weeks. Some of you are taking it in a couple of weeks after that. The SHSAT range is across a couple of weeks. So, in fact, I want to do another stream. I might do it later today, or maybe right even after this, because somebody contacted me about something that they're kind of upset about. Anyway, I'm not going to get to that in the scope. So we have an illustration. We have an XY coordinate with a line going 45 degrees, because I know that because 1 matches and 2 matches, and it's going off into infinity. We have that ray starting from 0 going outward. They're only showing us x from 1 to 2 and y from 1 to 2, and we notice that the bottom half of that area there, they're giving us something shaded here. So most likely they're going to ask us what the area that is. This is kind of a no-brainer. I'm almost not sure why it's there, so I almost wouldn't believe that that would be the question. So they don't give us anything else in the figure, so let's jump into the question. What is the area of the shaded region in the graph above? So that is it. That is the question. There's a couple ways to solve this. One way is to notice that the box here goes from 1 to 1. So this whole thing here is 1. So if this is cutting it at a 45-degree angle, then it's half of it, which means it's a half. In fact, this is so easy, I'm nervous what the answer is. So the answer should be 0.5. All right? We can also solve this another way, which is that if this is 1 and this is 1, that means our base and height are 1 and 1. And the area of a triangle equals 1/2 BH. So we get equals 1/2 times 1 times 1. And that's equal to 1/2. All right, so again, this is a throwaway one. So this comes down to make sure you read questions properly. I've keep repeating over and over. The problem with hard questions is they're hard, and the problem with easy questions is they're easy. This is absolutely, definitely throwing a point to everybody, and it would be a shame to lose the point here. And again, even if it's the 4-point point, but again, if you answered more than 40 questions correctly, you're going to get this. And by the way, when I talk about the 40 questions, I'm also including the field questions, so they don't count either way. So you could answer 40 questions, and if 7 of those 40 questions were the field, then you still only answered 33. All right, so you want to consider that. And when students are considering, you know, I'm doing well in the math section, I want to focus on the ELA section. You know, I get almost all of them right. This is part of the challenge of that, because first of all, you should be trying to enhance your strengths and weaknesses. But when you look at it and say like I'm getting 50 out of the math ones right, but what if 7 of those are always the field questions? You see what I'm saying? And it's the last few points. In other words, if you get 5 questions that are worth, say, 9 points each, that's 45 whole points. Or let's just round it up to 50. That's a good shot there at getting past the cutoffs. 50 points, right? Some of you are only getting about 250 points per section. That's about the average, give or take. So 50 points to bump yourself up to 300, hell yeah, do it, all right? So, and be careful, because I'm not saying don't spend time on the ELA. There's lots of points to focus on with the ELA and stuff as well. So be super duper careful. All right, so at this point, I'm gonna end the stream right here, and we'll jump into more of this. I might do another live stream later, just talking about a certain specific topic, which is basically which day to take the test. I'm really confused about something I'm hearing, and I think it needs clarification. And what I might do is actually draw up a table demonstrating my thoughts on the subject of what day to take the test. Also, I might even do the next section of this, because yesterday's live stream got screwed up, so I'm kind of off mentally a day. But in any event, there's enough time to go through this. So with that in mind, everybody have a great day. It looks nice out, and peace out. Don't forget to smash the like button.